Okay. Okay, so identifying the different types of chemical reactions. Okay, so again, I am going to review again what I said yesterday about synthesis and decomposition. And yesterday you did the assignment. You should have practiced those two. So hopefully with this next three, it will be a breeze, okay? So you do need to be able to identify each, okay? There's ways to remember these, and there's ways that we actually present to the students so they can remember the reactions. Okay, so like synthesis is really the, I don't know if you guys remember yesterday, I kept saying combination, you combine them. That means they get together, right? When they're getting together. Decomposition is when it breaks up. That's like when you die, you break into pieces, right? So single replacement is the cheater. Okay, so you don't know that one yet. So we're gonna talk, I'm gonna tell you a little story about the cheater. And then the double replacement is the swap. It's kind of a love story too, but they're swapping. Okay, so combustion is just like a bust. Think of it as a bust. That means fire. Okay, so so we're going to be looking at that. Okay, so the red names again, they're just helpful hints. Okay, so like synthesis, think of it like this. Okay, so basically it's like the perfect example I gave out yesterday. It's like the sperm plus the egg, and then it makes a baby, right? One product is the baby. Okay, so in here it's like the boy doesn't know the girl, and then they meet, they bond, and they marry. It's one love, right? So that's synthesis. It's really what the word means is really get together. It's making something new, okay? And it's only one new thing. And what makes it unique is that you're making one product, okay? So whenever you see those reactions and you see one product, really it's the only one in all the reaction that makes one thing, okay? They're all bonded in one thing, okay? So again, it's two or more chemical bonds together forming one new substance. Okay, and as you guys can see, you can also look at it in letters A plus B, and then A, B together. Okay, so I show you different ways visual so you guys could know it, so you guys could understand it. Okay, so again, these are, again, there's different types of chemical reactions, but these five ones are the main chemical reactions as a whole in this world. Okay, so anyway, so reactants are, this is just a refresher. Remember, reactants are on the left side, products on the right side of the arrow. Okay, now here I show you a chemical reaction. This is salt. So in the beginning, it's just Na, and then it's just Cl, and then you just put them together. That's it. You see how it's one product? There's no plus sign in the middle, okay? Which one? This little two? It's the to the front. No, but that two represents Na and Cl. Got it? Okay, good question. Very good question. Okay, awesome. Yes, ask me away, you guys. Please ask me. Okay, that's very, very important. Thank you. Awesome. Okay, the next one. Okay, so keep in mind that the coefficient is a big number. That's a number placed in front of the chemical formula in an equation. Okay, so anyways, so another one, I just added it in here because, so you guys, it's just another example. But this is an example right here also of the synthesis reaction. Unfortunately, we can't do, usually we have several reactions we do in the laboratory every year. It's like very, it's, you know, sacred. We do those chemical reactions. We turn on the Bunsen burners and you guys do all kinds of reactions. And then at the end, especially all these, but unfortunately this year is gonna be very, very different, okay? We cannot do that, especially because we're handling a lot of the chemicals and bottles that we get, that a lot of people are going to be handling. Okay, so unfortunately we can't do it, but I know we're going to do a lab based on videos, so we're going to work on that. Okay, so anyways, this is just an example of synthesis reaction. Okay, now decomposition, again, is the breakup. Okay, they're together and they break up. Okay, so here's like year one, right? And then you die and then you break apart, right? Okay, so that's again. Okay, so again, all of this you should be familiar. So like here, H2O2, you can break it up into water and oxygen. Okay, so you could tell the breakup with a plus sign. Okay, so another example, but I don't know. Oh, this one, I like this because you see how it says compound? Okay, and then on the other side it's like element and element, but really it can be a compound element on this other side too. Okay, as long as they break up, it's fine. Okay, so that's another example there. Okay, and that's mercury oxide. It does separate. Actually, mercury, you can see the mercury how it's separated. In here, it's mercury oxide, it's like a powder, but here you can't separate it. Okay, the next one here. Now we're gonna get to the new stuff. Single replacement. Okay, the cheater. Okay, so here, single replacement, you see how these were bonded? They were bonded together. However, he met a girl, another girl, and he left the other girl and he bonded with this new girl, the one in black. Okay, so basically he that's why we call it the cheater. Okay, so basically it's one element knocks another element out of a compound. So again, one element knocks another element. You see how she knocked her out? Like, oh, bye, see ya, because she took over, right? Okay, so that's what we call them, the cheater, single replacement. Okay, it's really just one. One element knocks another. So that's why it's single and it's replacing her. You see that? Okay, the next one. Okay, so again, sometimes we put it in letters. Okay, so A, B, and then plus X. So the AX are together. You see how they just swapped? Okay, and then this is a chemical equation. So I want you guys to look at it now. Look at it, okay? So you can see what swapped. What swapped? So zinc. So here, hydrogen, chlorine were the couple, right? So who's the one that took over? Who's a girl, the bad girl, or the girl in the dress? It's zinc, right? So you see how zinc and chlorine are here. They swapped, and basically hydrogen was left by itself. Okay, so you've got to see that one. Okay, that one that just replaces. And even the word, think about it, single, just one, and it was replaced. Okay, so just think of it like that. Okay, now I like this because I like the way it says it, like compound plus element equals a new compound plus a new element. Okay, I like that because you can tell also, because usually this one is an element. Okay, and the other one's a new element, and that's a compound. So it's usually compound element, compound element. So when you see the equation, if you see that compound element, that's usually the single replacement. Okay, at least if you know what a compound and an element is. Unless you just started chemistry, well, then that's a different story, because some of you, I don't know, I have some students that just barely started. Okay, so anyways, so this is just an example of single replacement reaction. And if you see it in the bottom, you can see that there was some movement. Okay, it can be tricky sometimes. You see how there's hydrogen, but you see how it's still, element, compound, or compound, element, it doesn't matter. Okay, if you see that compound, element, usually that's always a single replacement. Okay, now double replacement, you see how it's 4 on this side and 4 on the other side? Okay, so usually it's not compound element. It's like the other one was 3 on the left side and 3 on the right side, right? This one is 4 and then 4, okay? And sometimes it's a bulk, Okay, it's a both, but they're all compounds, all of them. If you see that they're all compounds, then that's a double replacement. Okay, so the swap is that it's basically this guy was with this girl, this guy was with this girl, and what happened? The girls, she fell in love with him, and the one with the red bow fell in love with the one with the mustache. So they just basically did a swap. Okay, so that's why it's double, that's two, and they both replacement, right? Okay, so again, two compounds switch ions with each other, that's why. You don't have to worry about the switch ions. I'm still debating. I'm going to teach that part, but for sure it's two compounds on each side. Okay. Okay. As you guys can see, you see the switcheroo. Okay, and then here's a real one. So you see, look at it. Okay, because students sometimes get confused, but you see how it's compound, 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 compound. Okay, so they're all compounds. Oh, is that double replacement? Yeah, it definitely could be because, I mean, we still have one more to go, but that one's easy. You can tell the difference. But usually, if they're all compounds, that means it's a double replacement. Okay, so the swap was that the SO4 moved over here and the chlorine went to sodium. That was it. Okay, you guys? Okay, let's go to the next one. You see how I put compound, compound, compound? Okay, that's the only reason I put that slide there. Okay. Okay, the next one. Now the last one. And you guys, combustion, like bust, explode, fire, that's combustion. They always have very similar characteristics, like similar elements, compounds, I'm sorry. Similar compounds. So basically, combustion reactions, it's when a hydrocarbon reacts with an oxygen gas. Oh, that sounds like so hard. It's not. Hydrocarbon, it's basically gas, you guys. It's fuel. It's the gasoline you go, and that's what we use for Bunsen burner. We need gas. Okay, so gas, that's made of carbon and hydrogen. Okay, so you always see a hydrocarbon there. It's like a CH. And it has different numbers, different subscripts, because you still, of course, have to balance the equation, but it always has a hydrocarbon. And then you need oxygen. So yes, oxygen is what makes things bust, makes things on fire. So this is also called burning. So in order to burn something, you need the three things in the fire triangle, okay? So you see that? Fuel, heat, and oxygen. That's a combustion, that's a chemical reaction, okay? So you need the fuel, which is a hydrocarbon. You need oxygen, and with a spark, that's your arrow, that's your yield sign, okay? So a compound burns in oxygen gas, okay? So compound burns in oxygen gas. This compound must be a hydrocarbon made of hydrogen and carbon. Okay, so combustion reaction. So that means the fuel is always going to have a carbon and hydrogen with oxygen. So yes, believe it or not, oxygen, the oxygen we breathe every day, it's what makes fire. But you got to ignite it and you got to have the fuel, right? So after that, all the fire that you see, it's all gas, it's carbon dioxide and water. So a lot of you are like, where did it have water? Was that so weird? Yeah, that's what it is, okay? So it's just, of course, gas, though. It is all gas, okay? So anyways, so products are always going to be carbon dioxide and water, okay? So combustion is used to heat homes and run automobiles, like octane, as in gasoline is a hydrocarbon of CH18. The only thing that's going to change is a little number, the 8 or the 18. It just depends what it is. Sometimes it's, I don't know, oil, sometimes it's gasoline, it's some kind of fuel, okay? So any fuel always has CH, which is called hydrocarbon. So anytime you see CH and an O as a reactant, right away. Okay, that's fuel, that's oxygen, you know, so that means bust. You bust it out, you use fire, okay? So that's flammable. Okay, so basically, that's it, you guys. Those are your 5 chemical reactions. And let me see, I think we have, let me see how much it is. Okay, well, you know what? You guys could see that one on your own. I do want to show you guys really quick this one. I like this one. I didn't get to see it all, but let me see. I did like it better.
There are 5 major classes of
Sorry,
chemical reactions.
typical, right?
A synthesis reaction is when 2 or more substances combine to form a single product. In a decomposition reaction, a compound breaks down into 2 or more simpler substances. A single displacement reaction is when one element takes the place of another in a compound. In a double displacement reaction, the positive and negative portions of 2 ionic compounds interchange.
Yeah, believe it or not, that's how what happens.
A combustion reaction occurs when a substance rapidly combines with oxygen to form 1 or more oxides and releases energy.
And that makes water and carbon dioxide. Okay, you guys, just a quick one. Now how to make a reaction occur. There's different ways that it has to occur though. You do have to have some kind of activation energy. There is a minimum amount of energy needed to start a chemical reaction. Okay, so like for example, for combustion, you obviously need a spark, like, you need heat. The rates of chemical reactions also vary. Okay, depends how much surface area. Like the more surface area it has, like say for example, I don't know. I'm sure you guys seen like maybe big salt. I'm sure you guys seen sea salt. Sea salt is like huge, and then there's some smaller ones. You would probably notice that it will dissolve faster, or it will, if it's smaller. So that's a surface area, okay? So versus a bigger salt, it will take a lot longer. So it's very similar to chemical reactions. So the more surface area that is exposed, the faster the reaction will occur. Okay, so another example would be showing your food breaks it down into smaller pieces with more surface area. It does take less time to digest your food. Also, temperature, the higher the temperature, the faster the particles move. This means they interact more often and have more energy. Also, another example is storing milk in a fridge slows down the reactions, and the milk does stay fresher longer. If it doesn't, it will react and it will spoil. And that is a complete chemical reaction. Okay. So also you can control it. You can control a reaction. There's 4 different ways you can control it. There's a concentration, like the amount of substance in a given volume. Increasing the concentration allows for more particles to react. Now, concentration levels, we're going to go really deep when we go into making solutions. Okay, so that's some, we'll get to that when we get to that. So catalysts and enzymes, I don't know if you guys remember biology, but that's how we are, at least. And there's a lot of catalysts out there, but it's material that increases the rate of reaction by lowering the activation energy. So believe it or not, you can control that energy, and you can control is basically you control that. You can actually control a reaction. You can actually control. You can have it in your hands. Okay, and enzymes is basically breaks it apart. Inhibitors are materials used to decrease it, so you can actually decrease the rate of reaction. So you get familiar with this, and you have those supplies. Basically, you can do a lot of reaction. You can control it. You can make things faster if you are making any kind of chemical reactions. Okay. So anyways, just FYI, I don't think this is going to be in the test. I just wanted to bring it up so you guys can understand that you can control those reactions. Okay. Okay. So anyways, I'm going to go ahead and that's it, you guys. We are done for today. We just make sure you do your assignment. I'm already getting good news here that you guys are getting good grades. So that is awesome. So it's really, again, use the notes that I put in there. So if you guys go in here, and I'm not gonna even bother going there because you guys, it's just really easy, okay? So you guys go in there, I put the notes up here, all you have, and they're balanced there for you. I was debating for you guys to balance it, but I was like, no, I'm gonna go ahead and let you guys and just identify it, okay? So just make sure you go in there and practice, practice, practice. Okay, you guys? And that's pretty much it, you guys. I will see you guys